I welcome all of you to this last part of our study of electrochemistry, and here we are going to study the applications of electrolysis. And in application of electrolysis we have three applications. The first one is electroplating with metals, the second one is electrorefining of metals, and the third one is extraction of metals, also called electrometallurgy. Now let's understand what is electroplating of metals. In electroplating of metals, we apply a coating on another metal so as to prevent that metal from corrosion or to increase its beauty. And in electrorefining, we try to prepare very high quality of metals, high purity of metals. We will see this in context with purification of copper and extraction of metals, that is electrometallurgy. We will see how active metals like mostly alkali metals are extracted from their salts. Okay, now electroplating. Electroplating is a process in which a thin film of a metal like gold, silver or nickel or chromium gets deposited on another metal or metallic article with the help of electricity. This is important. So we coat another metal with a metal of our choice with the help of electricity. This is the electroplating. Now the causes, reasons for electroplating. The first reason that our book points is the decorating purpose, and then we have the second purpose of protecting the metal from rusting and corrosion. Okay, decorative purpose, for example, brass objects are frequently plated with silver to give them the shining appearance and beauty of silver article. We see various gold plated ornaments in the market. So we also see hand watches, wrist watches. They are plated with gold to give them extra bright decent looks. And the next one is to protect from rusting and corrosion. Yes, we often coat iron with nickel to give it a coat and give it more longevity. We can use even chromium or zinc to coat iron, because in that case iron will not come in contact with the environment and it will not get rusted. Okay, conditions for electroplating. There are three conditions here, and I want to discuss all these three, and if there are more we'll discuss it again. The article to be electroplated is always placed at the cathode. This comes from the fact that during electrolysis cations goes to cathode and gets deposited there. So we must put the article to be electroplated on cathode so that and the other metal ions come and get deposited there. Okay, and the other metal will come from anode, that is the other metal will be taken as anode, and this anode will corrode away as metal atoms will form cations and they will come to solution. For example, if I have nickel, then this nickel atom will change to nickel plus and it will also give off 2 electrons. That is, the nickel atoms will convert to nickel 2 plus ions, and those nickel 2 plus ion will go to solution, and ultimately they will go to the cathode, and they in cathode this reverse reaction will occur and it will get deposited there. Okay, electrolyte must contain ions of metals which is to be plated on the article. Yes, if we took the case of nickel, then nickel 2 plus ions must be present in the solution so that it helps a steady flow of nickel 2 plus ions from anode to cathode. Okay, a lower current is preferred. A lower current for a longer time is preferred. Here in this case we get an even and strong coating. If we use a higher current, then it will cause uneven deposition of the metal, and longer time and low current indicates a thicker and uniform deposition. we cannot use a alternative current, because in alternative current the direction of current is reversed very frequently, and as a consequence effective electroplating is not obtained. Now here we are going to discuss electroplating of an article with silver, and in doing so we need to see the diagram. Here you can see that anode, that is block of pure silver, is taken, and in cathode a particular spoon, that is to be kept, I take it to be a spoon, that is kept here so that the pure silver can get coated on this cathode, which is a spoon indeed. Okay, now this spoon is first washed with caustic soda, or that is sodium hydroxide, then it is washed with hydrochloric acid, then it is washed with then it is washed with I should say distilled water, and then it is dried. After that it is put in the solution of the electrolyte. The electrolyte contains sodium argentocyanide. In modern terms we call it sodium dicyanoargentate. Okay, let's see it again. It is sodium within bracket silver within bracket Cn and 2. Okay, so this is dicyano. We should start with sodium dicyanoargentate 1. Its oxidation state is 1, so this is the name. Okay, and how is it prepared? It is prepared using silver nitrate solution. We take silver nitrate, make sodium cyanide, react with we get silver cyanide. This silver cyanide will again react with sodium cyanide to produce sodium dicyanoargentate. Okay, now this sodium dicyanoargentate will decompose to produce sodium ion, silver ion and cyanide ion, and water will dissociate to produce H plus and OH minus ions. Okay, now what will happen in the cathodes and anode? Cation goes to cathode, the silver plus ion will go to cathode and it will get deposited there, and the anode will corrode as silver atoms will convert to silver plus ion and get deposited there. Negative ions, Cn minus ion and OH minus ions, do migrate to the anode, but silver more easily gets converted to silver plus ion. That is why this reaction takes place. Okay, now things that are to be kept in mind, that the thickness of the coating will depend on the duration of the current burst. The length of time, if we increase the length of time, the thickness will increase. The process, in this process the anode will dissolve. Yes, obviously, as anode is converting to ions and it is getting deposited at cathode, so it will dissolve. The electrolytic solution contains the same concentration of electrolytes as electrolytes is consumed at cathode and it is produced at anode, so the concentration remains the same. Concentration is maintained at the same concentration. Okay, now the spoon is taken out of the bath repeatedly, washed several times with water, dried and polished. And now why it is repeatedly taken out, I don't know. I have no answer to this. Maybe to have an even coating, we may be doing it. Okay, we could have used silver nitrate in place of sodium argentocyanide, but we don't use it, and the cause is that if we use the silver nitrate, the precipitation will be very fast and will not get a smooth or uniform coating. So for this reason silver nitrate is not used. Okay, electroplating with nickel, this is the second option here that we have to study, and it's very easy. Now here an ammeter to check the current. This is the battery, this is the anode connected to the positive side. Okay, the anions will come here and the cations will go to the cathode. It is here. Okay, Let's clear this picture. Now what will happen? Nickel plating is done for an iron article mainly to protect them, and now the electrolyte is nickel sulfate, and this will convert to nickel 2 plus SO4 minus minus and water ionizes as usual. Cathode is to be electroplated. Cathode, the article to be electroplated is used as cathode. Okay, now anode is a block of pure nickel metal, and the reaction that occurs is that very obvious, nickel will get deposited at cathode, and anode, though we have SO4 minus minus and OH minus ions, but nickel 2 plus will come out from the bulk of the metal rod. Okay, now points to be noted. Point 1, article to be plated is always kept at the cathode. Obvious, we discussed this early. The electrolyte must be a solution of a salt of the metal to be electroplated. Yes, repetition of the facts of silver plating. The anode is made up of a strip of metal to be plated. Yes, repetition of the information we studied in silver. Okay, electrolytic refining of metals. This is the second phase of our study today. So in electrolytic refining, we pass electricity and make impure metal as anode and pure metal as cathode. So we take very small strips of pure metal here. So let's see if I can, yes, this one is the small one. We have many more. I can show you again. This one is this electrode, cathode, and when we continue electrolysis, the anodes, that is the bigger blocks, will corrode away and the cathode will become thicker and thicker. And you see there are small black spots here. These are called anode muds. The impurities present in the anode of silver, of gold, of platinum, etc., they will just get down, and we will collect it. So let's see what the book says. The impurities get dissolved in the acid, while some impurities get dissolved in the acid, while silver and gold, being insoluble, they don't dissolve, and they are present as anode mud. Okay, now let's continue our discussion. We can use electrolysis to plate zinc, lead, mercury, silver and copper. We can use electrolysis to purify zinc, lead, mercury, copper and precious metals like this. Now the last part, electrometallurgy. In electrometallurgy, we extract metals from their salts. Active metals present, mainly the group 1 metals, are very active. They have higher tendency to combine with the oxygen, so we cannot use our conventional reducing agents like coke, carbon monoxide or methane or carbon dioxide to reduce them, because they won't get reduced. So what we have to do is that we have to reduce them electrolytically, and in doing them we will take their molten salts. So we cannot take the aqueous salts, because in aqueous salts the electrolysis will not occur. Okay, and the cause is given here. If we see, active metals are not extracted from their aqueous salt solution by electrolysis. This is because the aqueous solution will contain H plus ion along with metal ion. On passage of electric current, H plus ion gets discharged in preference to metal. Thus the product formed at cathode is hydrogen gas and not the metal. So for this reason it is not done. Okay, we can take potassium bromide, molten potassium bromide. At cathode, potassium will come out, at cathode potassium will come out, and at anode bromine will come out. This is the reaction. We can take sodium chloride. Cathode will give sodium and anode will give chlorine. Very easy. Magnesium chloride, the same thing will happen every now and then. Cathode will give magnesium, anode will give chlorine. Okay, aluminium is obtained from electrolysis of alumina, and here The gas carbon lining of the electrolytic cell acts as a cathode. If this is the electrolytic cell, then there is a lining of gas carbon here. This is connected to some external source, and this one acts as cathode, and graphite rod acts as anode. So if this is the salt, this we will have graphite rods here. So we can have many, and they will get connected to the external source. This will act as anode. Okay, here we use pure alumina and cryolite and fluorspar. Pure alumina is taken, cryolite and fluorspar added to them to do two things. First of all, decrease the melting point of the mixture and increase the conductivity of the solution. These are the two causes for adding cryolite and fluorspar. Okay, the reaction that occurs is that this alumina will dissociate like this. At cathode, aluminum will get deposited, and at anode, oxygen will get deposited. We'll study this in detail when we study aluminum compounds. Thank you very much for watching. Wish you all the best.